Our next topic is effect of dielectric on capacity of parallel plate capacitor. Suppose that we have a parallel plate air capacitor first, having plates P and Q. Charge on plate P is positive, which gives it a positive charge surface density plus sigma, and negative charge on plate B, which gives a negative charge density minus sigma. Okay. Now, E is the external electric field applied between these two plates. Assuming that area of each plate is A and D distance between the plates. This is the distance between. Now we know that electric field E0 is equal to sigma upon epsilon 0, which is also equal to Q by A epsilon 0, because sigma is equal to charge per unit area. Now, let us introduce a dielectric slab between these two plates of thickness T. That is, distance between these two ends is T. Okay. Now, because of this positive plate, this dielectric slab gets polarized, and here we have a negative surface charge density, and here we have a induced positive surface charge density. Because of that, an induced field EP is developed, which works against the external field. So net field inside the dielectric is E, the reduced field, which is sum of these two, vector sum of these two, E0 plus EP. Okay, this is between these two. Now we know that this. Now let us examine here. In the gap, this gap and this gap, field is E0. Where there is no dielectric, field is E0, external field E0. And between the dielectric, inside the dielectric, the field is the reduced field E. Okay. Now the potential, therefore, potential V is equal to distance where the external field acts, that is E0 into the distance. Distance is total T minus T, because इसमें जो है, इसमें जो फील्ड है रिड्यूस्ड फील्ड यहाँ तक है, और ये गैप में एक्सटर्नल फील्ड E0 है. So we will get E0 D minus T plus the potential inside this will be the field in this dielectric multiplied by the distance the distance in which it acts. It acts in the thickness of the slab, that is T. Okay, so it will be E into T. Okay, now we know that dielectric constant K is equal to E0 ratio of external field to the reduced field, which implies that reduced field is equal to E0 divided by K. Let us suppose that this is equation 1, and we substitute for E equal to this in this equation. So we get V is equal to E0 D minus T plus E के बदले में लिखेंगे E0 by K into T. Now, taking E0 common, we get V is equal to E0 external field. अंदर बचेगा D minus T plus T by K. Now we know that E0 is equal to QA by epsilon 0. We will substitute in this equation number 2. So we substituting in this, what we'll get? We get C0A, so it will be here, it will be 1 by C. So V is equal to Q by C 1 minus T by D plus T dk. Now we know that Q is equal to CV. This is C0. Q is equal to CV. So substituting for Q, we get V is equal to Q के बाद में लिखेंगे CV by C0. यहाँ निकालेंगे इसमें से T by T कॉमन, T by T कॉमन बचेगा हमें 1 minus 1 by K. Okay. Now V and V1s are, so we will get C is equal to, यहाँ लिखेंगे हम, we will get C is equal to by यहाँ पर हम क्रॉस मल्टीप्लाई करेंगे. What will get? C0 is equal to C into 1 minus T by D into 1 minus 1 by K. So इसको डिवाइड करेंगे यहाँ, so it will be C0 divided by 1 minus T by D into 1 minus 1 by K. This is the expression for the capacitance of a capacitor with dielectric. Now, we know that this denominator 1 minus T by D is less than 1, which implies that C is greater than C0. Now, if T is equal to D, अगर थिकनेस बराबर हो जो डायरेक्ट्रिक हमने इसमें डाला है वो पूरा इसमें फिल करे यहाँ तक पूरा. So T will be then equal to D. So if we substitute in this T equal to D, then we will get C0 will be equal to 1 minus T by D, that will be 1, that will be 1 minus 1 minus into minus, that will be 1 by K, which is equal to C. So this will be, which will implies that ये K ऊपर चला जाएगा, 1 and 1 will cancel out, so it will be KC0 is equal to C. So the capacity of the capacitor with dielectric is increased by a factor of E, which is the dielectric constant. So increase हो जाती है कैपेसिटेंस बनिस्बत की एयर कैपेसिटर से ज़्यादा बढ़ जाती है. Again, we can also write as C by C0 is equal to K. So dielectric की एक और definition है, dielectric constant may be defined as the ratio of the capacity of a parallel plate capacitor with dielectric to the capacity of the capacitor air capacitor. ये एयर कैपेसिटर की है, ये विद डायरेक्ट्रिक है. तो एक और डेफिनेशन आती है, द रेशियो ऑफ कैपेसिटी ऑफ अ पैरेलल प्लेट कैपेसिटर विद डायरेक्ट्रिक टू द capacity of parallel capacitor with air in it or air capacitor. Okay. So effect is that by adding this this dielectric, the capacity is in capacity of a parallel plate capacitor with conducting slab. Again, let us suppose that we have a capacitor, air capacitor with plates P and Q, area of cross section A. This is positively charged and this negatively charged. Its charge density is negative, minus, and charge density plus Q charge or minus Q charge, which is this charge is due to the external applied field. So capacity of this air capacitor, as we know, is given by C0 is equal to epsilon 0 A by D, where D is the distance between these two plates. Now, let us introduce a conducting slab of thickness D. D is the thickness of it. Now, we know because of the external electric field, there will be an induced charge, negative charge density here and positive charge density here. So, since this is a conductor, equal and opposite induced charge, E induced, it develops inside the conducting slab, and E is in this direction from left to right, and the induced field E induced is from right to left. Since these are equal and opposite, so net charge inside a conducting slab is zero. Reduced field is zero inside a conductor. Now, potential V in the gap where there is no electric field is E0 external field and the distance up to which it acts. So it acts between distance D minus the thickness of the slab. So D minus D. And inside this it is zero. Inside the conducting slab it is zero. So total potential is E0. We are applying formula V is V by D is equal to E, और dV by dr is equal to E. ये फॉर्मूला हम यहाँ पर अप्लाई करते हैं to calculate the V. Now, we also know that E0 is equal to sigma by epsilon, which is equal to Q A by epsilon 0, where A is the area of this and sigma is equal to Q by A, charge density. So, substituting this equation 1, what we will get? We will get V is equal to Q A by epsilon 0 D minus D. Taking D outside, so V is equal to Q A epsilon 0 D 1 minus D by D. Now, substituting here this value, so what we get? Since we know that Q is equal to CV, substituting in this, so we will get V is equal to Q के बदले में लिखेंगे CV D A by epsilon 0 1 minus D by D. V1 by cross multiplying, we will get epsilon A0 by D is equal to C 1 minus D by D. Okay, now A by epsilon 0 D, that is the capacity of the air capacitor. So C0 is equal to C by 1 minus D by D, or C is equal to C0 by 1 minus D by D. Since 1 minus D by D is less than 1, which implies that D by D 1 minus D is lesser, so which implies that C is greater than C0. Thus, by introducing a conducting slab inside the capacitor, its capacity increases. Now, if T is equal to D, the thickness of the slab is equal to the thickness of the gap between the plates, then C T by D, it will be C by 0 So C will tend to infinity. So by introducing a slab which is equal to the width between the two plates, then when it completely fills it, then its capacity increases many folds. It becomes infinite. Okay. So this was today's lecture. Okay. Thank you.